Now, a couple more, and then we're going to stop and do a little regrouping before we move on. We're going to do C on our calculator in a second. Let's do D first. Find D inverse. All right. Anybody want to say anything about that? Find D inverse. What's the first step to finding an inverse?
Finding the determinant.
Yes, thank you.
Can't.
But you can't. Very good. If the thing isn't square, you can't find a determinant, right? And if you can't find a determinant, then you can't find an inverse. So D is what we call non-invertible. There's no inverse because it is not square. To have an inverse, you've got to have a determinant. And to have a determinant, you have to be square. Everybody good with that? All right. Then let's do number 5, and then we'll come back and get our calculators out. Number 5 says, here's matrix M. And we're going to find M inverse. All right. Step 1. Uh-oh. Why am I uh-ohing?
Determinant is 0.
Yeah, and why is that a problem?
Because then when you flip them and then divide by 0, everything's going to be 0.
Well, everything will be undefined. Remember, you can't divide by 0. So there's no point. Once you figure out that your determinant is 0, just stop. Because like he said, when you get this new matrix built, you're going to go through and divide everything by 0, right? By the determinant. And that can't happen. So you have another example of a matrix that doesn't have an inverse. So the moral of that story is, to have an inverse, you have to be square, and your determinant cannot be 0. Everybody good with that? All right, let's get our calculators out. And let's do problem C by hand. You guys are so lucky, because in the old days, we learned how to do all this by hand. But we're going to do it on our calculator. All right, so you got your calculator out. Okay, look at matrix C. First thing we're going to do is put that into our calculator. All right, so everybody's got a calculator. Everybody's paying close attention. Right here in the first row, or first column, I should say, of buttons, my fourth one down, I see the word matrix. Do you see it? So we're going to press second matrix. And that brings up a menu of items. The first thing we have to do is put these numbers into a matrix in our calculator. So you do that through edit. So click over to edit. Now, I don't know what's already in your calculator, if anything, and it doesn't make any difference, so don't worry about it. But number 1, it says matrix A, right? First thing you need to do, go ahead and press enter. And now the calculator wants to know, what are the dimensions of the matrix you're putting in? Well, C is 3 by 3, so just press 3, enter, 3, enter. And now you should see like a matrix with spaces to put numbers in. If there are already numbers in there from earlier work that you or somebody else did, don't worry, you can type right over them. So once you've told it it's a 3 by 3, then you start putting in the numbers. So 1, enter, -1, enter, 2, enter. That's the first row. Now, 0, enter, 3, enter, -1, enter, and 1, enter, 4, enter, 0, enter. Everybody good getting those numbers in? All right, once you have them in, then I want you to quit. So hit second quit, right at the top, second quit. That gets you out of the matrix menu. All right, so you're back to home screen. Okay? Now, go back in the matrix menu, so second matrix. And now you have a matrix A already in there. So press enter, and up on the screen, now it should say, literally on your screen, A with a matrix, or matrix sign with A inside of it. The matrix button, if you don't press second, is your inverse button. It's x to the negative first. So press that button, and then enter, and it gives you the matrix. The matrix, the inverse matrix, is -4, -8, 5, 1, 2, negative, oh, I don't have those lined up very well. 1, 2, -1, and 3, 5, -3. Did everybody get that?
I'm sorry, so after the second quick, what do you do after?
Go back in the matrix, second matrix, and then press your inverse button. Or enter, second matrix, enter, and then your inverse button. Okay? I have no idea what's going on here, but there's racket. Okay. So that's how, we're going to do some more work with our calculators later, but that's how you put a matrix in. Right now, for today, that's the important part. To put a matrix in, you go to your matrix menu and click over to edit. And then you tell the calculator how big a matrix you're putting in, and then you just put the number, put it in. We'll be doing lots more work with those in a little bit. Okay? You do not have to find a 3 by 3 by hand, but you do have to know how to find a 2 by 2 by hand like the ones we practiced. Alrighty, Daddy? Now, I want to pause for a second before we move on to some more new stuff. And I want you to take out a piece of paper and write down some review problems. Our next in-person day, which I don't even know when that is, but whenever I see you again in front of me in the classroom, we're going to have a quiz. And the quiz is going to be the kinds of problems that I'm going to do right now as a bit of review and practice. Okay? So that's why I want you to write these down. I also put these into Schoology, so they're there for you too in the extra practice review if you want. But I want to go through these with you right now so that you have a chance to ask any questions. Also want to remind you that on days 1, 3, and 5, we have office hours to work on current material. This is current material. So you are always welcome, even zooming in. I mean, I always have the zoom up to do that. All right, so the first practice problem looks like this. Excuse me. And the directions say solve. So this is a system of equations, and we're going to solve it. Now, all it says is solve. It does not give you any sort of, specific way to do it. So what occurs to you if you're going to solve this system?
Eliminate y.
Okay, you absolutely could eliminate y. You can't eliminate x, folks, because this one's squared and that one's not, but you absolutely can eliminate the y's. So I guess, Jacob, you want to multiply the top row by 2? So we're going to have 10x squared minus 2y equals 6. And then we're going to have 3x plus 2y equal to 7. So just like Jacob planned, the y's are gone. We're adding, so we have 10x squared plus 3x equals 13. Do not add these two together, folks. Okay, what kind of an equation is that?
Quadratic.
Yep, and what do we do with quadratic equations?
factor them?
Well, yeah, first you set them equal to 0. And I do believe that does factor. Now remember though, if it doesn't factor, or if you can't figure out how to factor it, or if you just don't want to factor it, what could you do instead?
Quadratic.
Yeah, you could do the quadratic formula, for sure. Yep, that works. All right, now what? What does that mean? What does that tell me?
Solve the x.
Yep, so it tells me that x is either gonna be negative 13/10 or positive 1.
Yeah.
So then what happens next?
You plug both those into one of the equations.
Yep, you plug them in. And given that's a fraction, I think I'll plug them in this one right here. It doesn't matter, plug it in wherever you want, but I think I'm gonna plug it in right here. So I'm gonna have 3, well, I'll do 1 first because that's the easiest. So it looks like 2y equals 4. It looks like y equals 2. Did you get 1 comma 2? And then I gotta plug in negative 13/10. Not gonna panic. This is negative 39/10 plus 2y equals 7. If you don't want to deal with the fraction, you could multiply everything by 10. So you'd have negative 39 plus 20y equals 70. Now you don't have any fractions to worry about. So 20y equals 109. So y equals 109 over 20. Now some of you are going to get bogged down in that arithmetic because you freak out every time you see a fraction. Just take your time. I have confidence in you. You can do it.
Miss Warren?
Yep.
For elimination, if every number cancels out and they all equal 0, do you just put all real numbers?
No. If you end up with something like 0 equals 0, then whatever you've got, whether they're lines, well, that would never happen in a problem like this because these are not the same curve. This means that they're the same curve. So we don't say all real numbers. We say same line, same parabola, same whatever. Can happen here because they aren't the same shape. And that only happens when they're the same shape. So what that means, Nicholas, is if you ended up with this, if you graphed your first equation with a red pen and your second equation with a blue pen, you would end up with a purple picture because they're right on top of each other. We used elimination here, which happens to be my personal favorite, so I was happy when he said that. But could we have gotten y by itself and substituted? Yeah. And it makes no difference. On this quiz, there will be no directions to tell you how to do it. You can choose whatever works best for you. All right, next. Okay, now we need to write these matrices down because we're going to do some work with them. So we have matrix A. So just like in the notes, you're going to have a string of matrices, and you're going to have a bunch of questions about them. I know there's a glare. I can't The only way to get rid of it is to turn off all the lights, but then I can't see. All right, so this is just our list of given matrices, and now we're just going to answer some questions. All right. These are just random questions. So there's the first 4 questions. All right, who remembers what this means? No one remembers? Well, this little b refers me to matrix B. The little letter means find a number in the matrix. The 2, 1 is the row and the column of the number I want to find. So this says look in matrix B and find the number that is in the second row, first column. So what number in matrix B is in the second row, first column?
2.
Yep, right there it is. Second row, first column, that number right there. That's the one we want. What are the dimensions of matrix A? Well, how many rows does it have?
3 by 2.
Oh, be careful. It's always rows by column. So how many rows does it have? How many rows are the bleachers? 2. How many columns does it have? 3. Rows go this way, just like the bleachers. Columns go this way. So this is a 2 by 3. Roman Catholic, rows then columns. Everything is always rows then columns. This one we just talked about today. To write the transpose, you take whatever is in row 1 and you make it column 1. So 1, negative 1, 5 is column 1. 0, 4, negative 2 is column 2. Notice that A was a 2 by 3, but its transpose is 3 by 2. Doesn't that make sense? Yes, because the transpose switches the rows and columns. So it used to have 2 rows and 3 columns. Now it has 3 rows and 2 columns. All right, now we're going to do a subtraction. So we're going to take matrix C, and we're going to subtract 2 times matrix D. Anybody remember what we call this number right here? It's called a scalar. Doesn't have anything to do with the problem, doing the problem, just a review of the vocab word. So we're going to take C minus 2D's. Now 2D's would be negative 210, 8, 6. So that is matrix C minus 2D's, 2 times these. Well, I can do that because they're the same size, so here we go. 1 minus negative 2, negative 1 minus 10, negative 2 minus 8, and 3 minus 6. Anybody have a question about that problem? next one, call this E. We're going to take matrix A times matrix B. So we're going to take 1, negative 1, 5, 0, 4, negative 2. That's matrix A. And we're going to multiply it times matrix B. Remember, sometimes that's not possible, so we'll want to check to make sure we can do it. Can we do it, guys? Is it a doable problem?
Yeah.
Yep. And we're going to end up with another 2 by 3. I put blanks there to remind myself, but you don't have to do that. You just need to make sure you end up with numbers in all those spots. Okay? So here we go. To fill this spot right here, we have to multiply the numbers in the first row times the numbers in the first column. So be organized. 1, negative 1, 5, and 1, 2, 3. So you multiply each pair and then add them up. I got 14, but I make a lot of mistakes when I do this, so make sure you are double checking me, guys. Is that okay? Positive 14?
Well, no, I think you're right. Yeah.
All right, let's move on then. We'll come over here. That's first row, second column. And I think that one is negative 7. And then finally, first row, third column. We got 28. All right, you go ahead and fill in that bottom row. So I'm going to use row 2. All right, that's what I got, but I want some help double checking that to make sure.
I think you're good.
I'm good? Thank you. Matrix multiplication. It's so easy, but you just have to stay organized, because there's a lot of stuff going on there. Okay. All right, so we got 4 more to go. And then we're going to have to be done for the day because we're running out of time. So using the same matrices, here are the next 3 questions anyway. Got to find the determinant of A, gonna find the determinant of B, and gonna find the determinant of C. All right, so tell me about F. Tell me about the determinant of A. Can't.
It's
Thank
not
you.
doable.
Not doable. So you either put an empty set sign, right, not doable. Please don't put 0 because it doesn't equal 0. It just can't be done. So, right, can't be done, not doable, empty set, some indication it's impossible. Now, B is possible. So we've done a couple of these. Remember, our process for a 3x3 is what? How do we find this determinant by hand?
Copy the first 2 rows.
Yeah, columns. Yep, first 2 columns. Here we go. Copy them right down. Including any negatives. Make sure you do them in order. First and then second. First and then second. And then we're going to start right here. We're going to start multiplying, right? So multiply. 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 I got a total of -1 for my downs. Multiply each diagonal and then add them all up. And then go the other way. So I got a 9, a 0, and a -10. Oh my gosh. This is kind of cool. So I got -1 for that one. What do I do with these 2 numbers now? These are my downs, these are my ups. What do I do with them?
Subtract.
Subtract. So it's -1 minus -1, which is 0. That determinant is 0. Now, it's neither here nor there. It's not on the quiz, but that means that if we tried to find the inverse of this matrix, we'd get an error. It's not doable. You can't find the inverse because the determinant is 0. All right, what's the determinant of C? I got 1. Did you get 1? My down diagonal is 3. My up diagonal is 2. And 3 minus 2 is 1. One more problem. Everybody okay with these determinants? All right, here's the last problem then. These are your potential quiz problems. Every problem on the quiz will be like one of these. The quiz may not have this many, but this is what the quiz problems are going to be like. All right, the last one, this would be letter I. Find the inverse of D. So here's matrix D up here. We're going to find the inverse of it. So the first thing, you're going to find the determinant. So what is the value of the determinant of matrix D?
-23.
Okay, I'm hearing 2 different answers. We got to be careful.
I think Nicholas is right.
He is right. Because you get -3 on the downs, you get 20 on the ups, but you have to subtract them. So that's -23. Now, the second part of the problem is you build your adjoint. And remember to do that, we take these 2 numbers right here and we flip them. So the 3 will go here and the -1 will go here. Then what do we do with the other 2? What happens to them?
You flip their signs.
They become opposite. So yeah, I want you to be careful. We don't really, I don't, their signs don't have anything to do with each other. So I'm not really flipping their signs. I'm changing their signs. So +4 becomes -4. and positive 5 becomes negative 5. And then what do I do to get my final answer, my inverse? What am I going to do?
Divide by negative 23.
Each of these guys is going to get divided by negative 23. And then you do any reducing. In this case, all we can do is cancel out some negatives. So we'll have negative 3/23, positive 5/23, positive 4/23, and positive 1/23. And that is your inverse. If you had extra time on the quiz and you wanted to check that answer, remember, if you multiply your inverse times your original matrix, what should always happen? If you've got the right answer, what should always happen? They cancel and make the identity. Okay? Now, next time I see you, is that tomorrow, I hope? Oh, no. Well, whenever I see you again, we'll continue on in the notes and learn more stuff on our calculator and by hand. But the next time I see you in person is when we'll have this little quiz, okay? Office hours if you need more practice on any of these kinds of problems. Everybody good? All right. Have a wonderful day.
Thank you.
Bye.
Thank
You're
you.
welcome. Kunkel, are you awake? George, are you awake? They all showed up except Solar. Tyler, you need to wake up. I got another class coming in.
Sorry, I was in the restroom.
Uh-huh.
I missed Ford.
Hello. Did you guys end up winning last night?
Yeah, we won 9-2, 4, 5.
I think they had 5 when I left. So yeah.
Yeah.
You guys
watched it?
I was there. Yeah, I watched. I did not realize how cold it was going to get, so I didn't stay for the whole thing. When you guys were on a roll, though, I mean, you were just racking up things like crazy.
Yeah. We ended the game early, like in the 5th inning, because it was getting dark too. So we got to finish early.
Oh shoot! I think I forgot to turn my